From the tiniest particles of matter to microscopic organisms, the world of the extremely small is full of wonders that can barely be fathomed by the human eye. Advances in technology have allowed scientists to measure things so small that they almost defy comprehension. Here are the top 10 smallest things ever measured, showing the incredible scale of the microscopic world. 1. Planck length. The Planck length is considered the smallest measurable unit of space, roughly 1.616 times 10 to the minus 35 meters. At this scale, traditional physics breaks down, and quantum gravity takes over. It's so small that it's beyond the reach of even the most advanced microscopes. This minuscule length is theorized to represent the scale at which the fabric of space-time itself may start to show quantum effects. 2. Subatomic particles, quarks. Quarks are among the smallest known particles that make up protons and neutrons. They are theorized to be point-like particles with no size, meaning they have no measurable volume in the conventional sense. These particles are essential in understanding the structure of matter, and their size is so minuscule that they can't be measured directly by traditional methods. 3. Atoms. Atoms, the building blocks of matter, are incredibly small, with a typical diameter of about 0.1 nanometers, or 1 angstrom. The atom consists of a dense nucleus, made up of protons and neutrons, surrounded by electrons, which orbit at various distances. Despite being so small, atoms make up everything in the universe, and their arrangement determines the properties of different materials. 4. Electrons. Electrons are subatomic particles found in atoms, and their size is so small that they are often described as point-like, with no known physical size. While their mass and charge are well understood, determining their exact size remains a challenge. Electrons orbit the nucleus of an atom, playing a key role in chemical reactions, electricity, and magnetism. 5. Protons and neutrons. Protons and neutrons, the particles found in the nucleus of an atom, are also incredibly small, measuring around 1 femtometer, 1 times 10 to the minus 15 meter, in diameter. While these particles are larger than electrons and quarks, they are still far smaller than anything observable with the naked eye. Their size plays a significant role in the atomic mass of elements. 6. Neutrinos. Neutrinos are subatomic particles that are even smaller than electrons and have a very tiny mass. These elusive particles interact very weakly with matter, making them difficult to detect. While their exact size is still uncertain, neutrinos are so small that trillions of them pass through your body every second without you even noticing. 7. Virus particles. Viruses are another example of things that are too small to be seen by the naked eye. The size of viruses varies, but they typically range from 20 to 300 nanometers in diameter. To put this into perspective, many viruses are smaller than most bacteria, and they can only be observed with an electron microscope. 8. Carbon nanotubes. Carbon nanotubes are cylindrical structures made from carbon atoms, with diameters typically ranging from 1 to 100 nanometers. These tubes are incredibly small yet strong, with remarkable electrical and thermal properties. They are a crucial part of the developing field of nanotechnology, and their unique properties make them useful in a wide range of scientific applications. 9. DNA molecules. DNA molecules, which carry the genetic instructions for the development of all living organisms, have a diameter of about 2.5 nanometers. The molecule itself is incredibly long, with the human genome spanning approximately 3 billion base pairs of DNA. While the individual strands of DNA are small, their structure and complexity are essential for life as we know it. 10. Quantum dots. Quantum dots are semiconductor particles that are just a few nanometers in size. They exhibit unique optical and electronic properties that make them useful in applications like medical imaging, solar cells, and LED technology. Their small size leads to quantum effects, which result in different behaviors compared to larger materials. The world of the incredibly small is a fascinating realm that challenges our understanding of the universe. Whether it's the tiny particles that make up matter or the microscopic organisms and molecules that drive life, these measurements show just how much exists beyond our perception. As science continues to advance, the boundaries of what we can measure and understand on the smallest scales will only grow, revealing more about the fundamental nature of reality itself.